Hey everybody, this is Mr. Munson again, Unit 2, Circles Continued. This is one of my favorite sections just because most of the material is brand new. And so to me it's kind of exciting. So here we are over on the right-hand side is our student learning map, and then kind of an enlarged view of the section we're looking at, which is coming from this area, second page, okay? So there's a list of I can statements. Those are what I'm expecting you to be able to do when we're finished with this section. Let's move on. So right now, so far, when it comes to arcs and angles, we have these two scenarios already covered. We have an angle here has a relationship to the arc that it cuts, right? And so that's that inscribed angle equals half the arc that it cuts or intercepts. Then over here on the right-hand side, we have another relationship. This is a central angle. The angle's vertex is at the center, and so the relationship that has is that the angle and the arc are the same. Okay, so if you did not put those in your formula sheet last time, you want to make sure you put those in this time. Let's move on to the new material. So here we have a vertex on the inside, but off center, right? So the center of the circle might be right about there. So this is a case where the vertex is inside the circle, but off center. And then below we'll have the vertex outside the circle, and it creates a relationship to two arcs. And we're going to investigate that now. So these are the three basic scenarios that we're going to be looking at. And so what we find is that the measure of the angle that's formed by the vertex outside the circle, we'll call it angle 1, that relationship or that angle is equal to half of the big arc minus the small arc. Okay? So that scenario just plays out on every one of these drawings. Let's look at the other ones. Okay, so we have angle 1 here. And then we have the big arc minus the small arc. Okay? And then over on the other one, angle 1 would be here, and these are two tangents. And we have the big arc and the small arc. Okay? Let's get that the right color. Okay? So, interesting enough, in this scenario, the two arcs go together to form a 360-degree relationship. Over here on this one, there's a piece of the arc that we're not going to have as part of the final calculation. However, sometimes the information given there will lead us to the big arc or small arc. And the same thing is going to go with these pieces. Sometimes that's information is going to be put there, or some concepts going to allow us to use that information to build what the arcs are that are inside the lines that are forming the angles we're talking about. Okay, so just make sure that you understand that in all these scenarios that we have a relationship between the angle that's formed by some lines that meet outside, and it's equal to half the big arc minus the small arc. Okay, so go ahead and use the formula that we just came up with, that relationship in the previous screen. Use that to apply to this problem. Go ahead and put me on pause and then check back to see if your work is correct. Okay, I'm going to write down the relationship first without anything in it. Champions do that, okay? If you're struggling with these things, it's because you're skipping that step. You should write the relationship down without anything in it every single time you do a problem, and you'll memorize these. And there you have it. The measure of that exterior angle there is 59 degrees. Hey, I'm going to do that one more time over here as a different way. It's the same thing, but instead of having that 1/2, I'm going to just say it's divided by 2. If you're good with that method, skip the next part, or just take a few more seconds to see this alternative way. Dividing by 2 is the same thing as multiplying by 1/2, so I could use the relationship in this form instead of having the half out front. It's whatever you like. Same answer, just an alternate setup. So you choose how you want to write your equation or remember it, okay? Up to you. All right, so in this one, we're going to be looking for an arc instead of an angle. So let's look at the setup on this one. Okay, first of all, we need to have numbers in the problem, so there you go. So let's go ahead and put me on pause, apply that same formula to this problem. Now we're looking for an arc, so you're just gonna have to put that X where an arc belongs. And keep in mind that this is your big arc. Okay? All right, here we go. So you're gonna put me on pause and then come back and check your work. Okay, so remember, dividing by 2 is the same thing as multiply by a half, so no big deal. You might multiply both sides by 2. You might take that 1/2 and send it through, whatever you like to do. But in this particular scenario, I'm going to multiply both sides by 2 to get rid of that division by 2. And of course, that cancels out, and I end up with 92 over here, and x minus 36. And there you have it. Okay, so the angle there, or the arc there, is 128. Okay. This is an interesting problem here. I'm not going to go all the way through it. It's more of a technique, an idea that we want to find this x here, kind of an angle thing, or an arc thing. And I just realized it said angle up there, and I should say arc at the very top. So anyway, the problem is that we have, this whole idea of the measure of an angle is equal to the big arc minus the small arc divided by 2, or multiply times 1/2. And so I can clearly see my small arc relationship here. It's the large arc that I don't have anything for. Okay, so to do this, I can take the small arc information and the angle information and put it in the problem. But see, I don't have anything for the big arc. So I got to think of some way of expressing this yellow arc knowing what x is. So I'm going to tell you, and I want you to think about this, okay? I'm just going to flat out tell you how to write the expression and see if this makes sense. How about if I said the yellow arc was 360 degrees minus x? Doesn't that make sense? X is one side of a circle, the yellow is the other side, so whatever x is, I would subtract it from 360 to find it. So now it's just a matter of plugging that new expression that I created in reference to x to solve a very complicated problem that's no longer complicated. Okay, so there's your equation, and I know for a fact for some of you, you're going to look at that equation and get kind of freaked out. If that's you, you need to come see me after school or ask me during the practice time, how to manipulate that. I got to tell you, me doing it for you is not going to make a difference. You need to do it on your own. So really try to struggle through that on your own. I would start with multiplying both sides by 2 to flatten out the equation, and then look at combining like terms. Remember, that is a 360 minus x minus an x, not times a negative x. So no distribution property here. Okay, here we have it. We have an angle and arc that meet on the inside, and they create a vertex at the center, or not off center from this circle. Okay, so it's not at the center at all. And so what ends up happening is, for instance, you can see this angle 1 right here. That angle 1 has a arc that it intercepts. Okay, so what ends up happening is that angle cuts that yellow arc, and it's kind of part of that angle. But if you think about it, the vertical angle on the other side is exactly the same angle, right? Because vertical angles are congruent. And so there's another arc that's associated with that same size angle, right? So there's this arc over here. Now, it'd been really nice if angle 1 is equal to the yellow and 2 is equal to the green, but that couldn't possibly be true because they're the same size angle. So since it's off center, what ends up happening is you end up with a relationship where you're adding them. So what's kind of interesting is the previous example where the vertex was outside the circle, you subtracted the 2 arcs that were associated with the angle, and in this one you add them together. So make sure you write that down in your formula sheet. Make sure you understand where the pieces would go. Okay, and then you just simply plug the stuff in, whatever piece you're looking for, and you're off and running. Okay, here we have the scenario, just like in that theorem and that relationship I showed you. Go ahead and put me on pause. See if you can use these numbers to create a problem and a relationship, an equation. Solve that thing, and let's see if you got the same thing. Put me on pause, and then check your work. Okay, so here's the thing. There's this whole big arc, small arc thing, when we're subtracting numbers, we need to make sure we always subtract from the largest number. When we're adding numbers, it doesn't matter. So I'm just going to use the notation big arc plus small arc, but it really doesn't matter what size it is. So I don't want you to fret over it. Obviously, when I have both arcs, I can put the numbers in the correct place. But if it's just an unknown, it just holds a spot for us. Okay, so go ahead and keep on watching my information. Okay, and I initially forgot to put in my divide by 2. I can multiply by 1/2, it doesn't matter, and there I have it. Okay, so the angle x is going to equal 198 degrees. Okay, let's move on. Okay, in this scenario, I'm looking for an arc. Okay, so go ahead and set up the equation. You just use big and small arc to reference the unknowns when you're writing your relationship without any information in it. Go ahead and solve it, put me on pause, come back and check your work. Okay, and don't bother worrying over if it says 110 plus x or x plus 110, because two numbers added together just doesn't matter. And there you have it. X is equal to 90 degrees. Okay, and there's your try it problems. All right, have a fantastic time with those. See you next class. Hope to have 100% in your class getting that correct and doing it right.